Yes, hello my dear students. Welcome back to the St. Joseph Composite PU College, Vijaypur. I'm Rahul, chemistry faculty. In this video, I will discuss a very small topic known as ideal solution. Most of the students learn ideal gases and non-ideal gases in states of matter class 11th. But right now we are discussing about ideal solutions. Very easy concept is there. We'll discuss this. And for this, what I need, the how solution is formed. The solution is formed by a combination of solute, and that should combine with solvent, and that leads to the formation of solution. Okay, there are two important factors are there. The one is enthalpy of mixing, enthalpy of solution, you can say that, or as enthalpy of mixing. This is some in other text this term is mentioned like a enthalpy of solution. The second one is the you can say that volume of mixing. Okay, now we can understand this factor by taking one simple example. Now assume that I have two molecules here, or two particles, generally two particles. These are the two particles. Now these two particles, I consider them as solute particles. These are solute particles. Solute. Okay, in the same way I will take two more particles. These are the two particles, and these are called here as a solvent molecules. Yeah, solvent. Okay, now between the solute particles there is a force of attraction. Let me take this, a force of attraction that holding the two particles, and here also there is a force of attraction is there between the solvent particles. Okay, the force of attraction in the solute particle is maybe different as compared to solvent, or it may be equal also. But when solute and solvents combine with each other, they're forming a solution. In the solution you should know that, let me draw a container here, and through that we'll see this. So I will take these two solute particles. These are two solute particles here, and also I will take here these two solvent molecules, or two solvent particles. Okay, now when solute and solvent start interacting, the force of attraction exists between the solute and solvent get removed off. There is no interaction right now between the solutes and between the solvents. Instead of that, a new interaction is formed between the solute and solvent. You can see that. Hope you understood this. Previously there is interaction between the two solute particles or between the two solvent particles. Now there is interaction between the solute and solvent interaction. This is known as solute solvent interaction. Solute solvent interaction. Okay, now only fact is here, if there is a condition, students, if whatever the interaction is there between the solute particles and whatever the interaction is there between the solvent particles, if it is exactly equal to the solute solvent interaction, there is no change in the enthalpy, or even there is no change in the volume. Okay, so let's understand this. So enthalpy of mixing, delta H mix is equal to 0, because the strength of bond broken and strength of bond formed is always equals when there is a ideal solution is forming. So therefore in this case enthalpy of mixing is 0. It means that there is no change in the heat content of the system. No change in the heat content of system means it is constant. Why it is constant? Whatever the bond is broken between the solute and solvent, whatever the bond is formed between the solute and solvent is equal, and therefore there is no change in the enthalpy. The enthalpy of the system remains constant. Now if there is delta V mix equals to 0, means the volume of mixture is equals to 0. Means whatever the volume of solute you are taking and whatever the volume of solvent you are taking, when you mix together, they should be added up. Okay, so added up means what? If assume that two liquids you are taken means liquid may be 1 liter plus 1 liter, that equals to 2 liter you will get, right? If you have the condition. Condition is only when the whatever the interactions are there between the solute particles and whatever the interactions are there between the solvent particles, if they are exactly equal to solute and solvent interaction, then 1 liter of solute plus 1 liter of solvent gives rise to 2 liters. In case solute solvent interaction is very strong as compared to solute and solvent interactions, in that case volume is less than 2 liters. If the solute solvent interaction is very weak, then the given volume solution volume of solution is greater than 2 liters. That we can discuss in the non-ideal solution. Don't worry about it right now. Okay, now let's go with this change in the volume. So why change in the volume is same? Because the interaction between solute particles and interaction between solvent molecules, solvent particles, I would use particles are equals to solute solvent interaction, and therefore there is no change in the volume. Then in that case we can say that the volume is additive. It is 1 liter plus 1 liter gives rise to 2 liters. No change in that. Now what examples we can provide here? Examples. Even we can say that there is no such ideal solution is there, but we can produce some examples right here, like benzene and toluene. We can take benzene plus toluene. We can take an example. Even you can take that toluene. You can take n-hexane and n-pentane. N-hexane plus n-pentane. Or you can take here chloroethane plus bromoethane. And one more example we can list out here. The one example is that chloroform and dichloromethane. Chloroform plus dichloromethane. These are the few examples we can provide. These are the not sure examples, because these whatever the mixtures are there or solutions are there, these are ideal only when there is certain conditions are provided, means at particular temperature and pressures are provided. In that case only they behave like a ideal, means when they mix each other the enthalpy change is 0 and volume change is also 0, because the interaction between the benzene molecules and interaction between the toluene molecules are exactly same as the interaction between the benzene and the toluene molecule. Right, these are the things we can list out in the ideal solution. In the next video, I'm going to discuss only about the non-ideal solutions, and 9 non-ideal solutions are divided into the solution which shows positive deviation from the Raoult's law, the one which deviates from, I can say that negative deviation from the Raoult's law. Right, this is all about. And one more thing I forgot to explain you that we can give a definition for the ideal solution, like the ideal solution is one which obeys the Raoult's law and all. Let me, that is not important, anyone can understand that, but this concept is very important. Hope you understood this all. Thank you for watching this, students.